everybody hear me? Okay. Today we're going to talk about infrastructure as code. In this presentation, I'm going to make a brief run through the history of infrastructure as code, and I'm going to draw the parallels between what you would consider traditional coding. Just for me, one quick show of hands, who has used configuration management before? Okay, there's quite a few. Bit of my background, so you know why I'm speaking here. I'm mainly known because I organized the DevOps days, but I've been involved with Puppet and Chef community very early, presented at Velocity, writing on books and open source projects. That's what I love. I work at Atlassian on the on-demand SaaS platform, and you can find me kind of pretty everywhere on the community. So if you need to reach out to me, please do. So these are the list of configuration management that I think are the main configuration management systems out there. CF Engine was the first, then came Puppet Labs, Chef, Palette, and Ansible, kind of the new kid on the block. But I do want to say I'm sorry, I can't go into detail of each of them. They have their strengths and weaknesses, but my experience is based on Chef and Puppet, so I'll be mainly talking about those. But do know there's like two main others out there, Ansible, Palette, and CF Engine. So do have a look at them, but I can't include like every different thing here. In the essence, configuration management or infrastructure as code is actually a declarative language. You say, this file goes like this. Package needs to be installed, service has to be up, and a file has to exist. That's what we do it for. I think it's different than the traditional coding where you can have like all different real-time loops and whatever. You just, in infrastructure as code, you define how the system should be. So you go from one state in the system, you do a code run, and then it goes to a next state. That's infrastructure as code, config management, that's what you do. So the system will converge over multiple runs to the state Y that you want it to be. That's the essence of configuration management. An important thing is that if I run the code again from a state Y, which is the end state that I wanted the code to be in, and if I run the code again, it will stay in state Y. Idempotence, but it's the power that I can rerun the same script over and over again without changing anything of the system if it's in the state that I want the system to be. Very important. It's when you convert your traditional scripts to configuration management, that's one of the first things you will hit. Like, hey, when I run the script again, will it give the same output? So it's an important part of configuration management. So you're all here because of the code, so I'll show you some language. This is how Puppet and Chef declare that you have an Apache running. It's slightly different syntax, but you see the same verbs like a package, a service that needs to be installed. This is what you would expect. People compare it for sysadmins often. If you know how to configure an Apache config file, you can probably write like infrastructure as code because you define the config of the state that it needs to be. In reality, I'm afraid it's a bit more complex as an Apache config file, although those can be complex as well, so I'm not denying that. The terminology, if I compare it to Java, okay, Puppet and they call it manifest, the Java files, and recipes is what Chef calls them. If you group them together, in Puppet you would get a module, and in Chef you would get a cookbook. So it's kind of when you translate it from your Java world, like where do I find my stuff, this is how they apply. To make it confusing, Puppet has something called a parameterized class, something you would think that's a class, like install Apache, like we saw in the previous class. But it's actually a singleton. A class can only be installed once on the system. So you can only install like one Apache. If you want to move to install multiple packages or multiple systems from Apache, in Puppet you have to go through a define. This is something that's confusing. A lot of people coming from OO world starting to use Puppet or Chef, they think like, okay, what's the concept of class? Well, let's take this. So it's actually, in my opinion, better to directly start with defines and not use parameterized classes, because that gives you the flexibility to always be able to install multiple of these. Unless you really, really want to have a singleton, that's what you do. In Chef, they call it a recipe with attributes and definition of libraries. It's just, let's say the differentiator is quite subtle, and the guys from Puppet want that classes never existed, that they never went with that term, but that's how it is in the language now. But be aware if you go to one of these languages. The syntax is a DSL. Like a config file, it's a limited set of words within Puppet, very specifically. You can extend these by going to definitions or things like resource providers or libraries, but the strength and the weakness of Puppet is that it really, by design, limits the DSL or the terms you use. This makes it easy to adopt because there's only a limited set, but when you get more expressive in your language, that's hard because you have to reinvent and circumvent that kind of restrictive DSL by design, which you can, but it's less designed to do that. Whereas in Chef, they kind of go from there from the beginning. And why is that? Because it's a DSL mixed with Ruby. So any construct you can get in the Ruby language, you can mix in with that DSL. So there's a tendency of sysadmins that's kind of going, we've never scripted, we never developed before, just give us a limited set. They kind of have a tendency to go to Puppet because, it's kind of boxed, this is what we do. When you want to have more expressiveness and kind of have a more development background, people tend to go with Chef. It's not the only reason why people should use Chef or Puppet, but it's a tendency I see from people choosing once they get into the field that the expressiveness you can do more in Chef. A simple example of that is that Puppet, for example, doesn't have a loop. You cannot do for A to whatever, or while true, or whatever. This is by design. So the only thing you could do that is pass your class or your define as an array of things it has to go through. But there's really it's not made easy for you to do looping. Whereas in Chef, you can do whatever you want. It's just native Ruby and mix that in. Just to be aware when you choose it, that's kind of a big differentiator between both. Then a smaller one, it's Puppet has, again, a new construct for string interpolation, whereas Chef uses the simple one from Ruby, the hashtag, the other one has the $sign. It's not something spectacular, but something you can compare both languages with. If you're doing object-oriented, you want to extend like a module very easily. If you look at that from a traditional or a Java or whatever language perspective, the language will be made to do that, where I see little use of inheritance actually in recipes, both in Puppet and Chef. They would just take, this class or this define doesn't suit me. I'll have to write my own, and that will take over the whole class. This kind of, you can add attributes with the plus operator in Puppet, or you can say, I override like a template file that in my own module with the cookbook. But it's not what you expect, like, hey, I'm just take my class, override some parameters, and then inherit in the previous one, and just go the whole chain of inheritance. You can think of it as another way, as in Java you have your module path. If your class file is just before that, you can override classes, and that's kind of also how you can do overriding in Puppet or Chef, by placing it in your cookbook path or your module path. Like any Java project, both have their own set of structure. You see, files that I include, library, my manifest, templates. So it's kind of like when you create in your Eclipse a standard project, you'll get a set of directories that are useful to create within the project. Another fundamental difference is the execution model. Puppet works in a way that I start with a file, and that file, the next step is to install a package, and then the next step is to install a service, because I need a config file first, then I need my Apache config installed, and then I can start the service. So there's a dependency tree between all these different parts, and in Puppet you would say one before the other, or one after the other, and that creates like a directed graph how you proceed through your whole modules. The danger is if you don't specify a dependency, it can randomly take place. Like if you really have to make certain that the order is specifically specified. That's one of the reasons why the people went to create Chef, because in Chef, like a Ruby language, it's just like sequential. You just go, if I define a service first or file first, I will always run the file first, then the service, and so on. So it's kind of a fundamental difference between both of them. The nice thing of a directed graph is that you have a model how everything's structured in your code. So you can use that as a meta information. What comes before the other? What if I change this part here? Whereas in Chef, you kind of have to run through and see what happens. So it's a fundamental difference. There, one of the pros is, in Puppet, thanks to the graph, you can predict what's going to happen. Better than you can predict with Chef what's going to happen. People from Chef will say that that will lie because it's not an actual system. But it's important, for example, if you do enterprise or legacy work where you're not in a cloud environment that just spin up a new VM and see what happens and it will do a run. If you only have one system you can do the run-up, the catalog and the fact that you can query the meta information on what's going to happen is very powerful. It's almost like refactoring your code and knowing what's going to happen if you're refactoring that machine. They both have a way of writing plugins. So if you have like a new command, this is more on the CLI base because a lot of them are running through CLI. You can extend your own little plugins if you want, or reports. After a run, they report what changed and stuff like that. So it's kind of similar at that perspective. So this was a very quick overview of the code itself. But if you release a new language, the first thing you do is like, okay, I need to write an editor that can edit that code. Okay, let's start with a lexer. There's a few lexers out there for Puppet, and they're actually used on GitHub to render what code that you want to do. Of course, the lexer is not everything. So the first editor, is basic. If you're a systems guy, you use VI, Emacs, or whatever, and they all have like syntax highlighting, and that's the way you work it. Of course, I know you guys don't take that for granted. So luckily, there's a company who created Geppetto, which is an Eclipse IDE that you can edit your Puppet code in. So if you're more familiar with there, which I guess you are if you're coding Java, have a look at that. It's a plugin. It's actually not a plugin. It uses the Eclipse framework to edit and do that stuff. It's not that it's a plugin as a different language. There's a few others coming. RubyMine is coming with Puppet support and so on. So I guess all these tools that are the traditional editors that will just move on and make it somewhere in a Puppet or a Chef language. We have the code and the editor, but think of it, when you have an existing server, are you going to define and write the code of that existing server? So there's a kind of reverse engineering tool that allows you to run the tool, and it will spit out what it knows, like the packages that are installed, the services that are running, the users that are created. So you can use that as a base, as a starting point for your code before you start editing. Obviously, they can't guess everything, so they will kind of probably generate too much. But it's a good way of kind of running it on a legacy system and see, hey, what's out there? If I have this list, if I just change one thing, it'll probably be repeatable. So it's a good way of looking how things are structured. So we got the code, kind of the syntax, and then we got like the editor, which, okay, It's still like early stages in the IDE, but it works. The coding style. So initially, a lot of people just started coding. So what happened is that after a while, the community was using different styles. Like I was doing parameterized classes like this. He was doing it like that. He was like doing the multiple spaces and so on. So finally, somebody got the right idea. Like, hey, can we write a lint-like thing that actually analyzes our style from our code? Again, something we borrowed from the regular code, but funny that it took us about 3 years to come up with a tool to do that. But it's like a lot of these things in the infrastructure as code. All the tools are evolving, but the community is using it more and more, and then these things just come up. It's not like Puppet or Chef are not actively working on the tools that enhance the language. They focus a lot of the language and their server and client, but the community was kind of worried about the cookbooks and the style that's happening there. It's simple things like 80 character line width or errors that need to be aligned so it's more readable. But it could even go more complex, like a service has to always specify what state it is in, like is it stopped or started? So very clearly, so that way you can avoid problems or conflicts in the code. So it's a simple test you can run through your code and it will spit this out. Another thing that the community learned, again, after only a few years, is that when you specify a class and you give it like arguments, it might be a cool idea to check the arguments and not just give them through and run them. So this is an example of using a schema that specifies what you can pass to the class bind, what kind of parameters it does allow or not. It's a simple thing, but it can save you like a lot of hassle by other people using your class that you haven't checked this. I know this probably sounds weird, but it's input-output checking is even in the DSL quite important because they're just passed often as parameters through the exec on the system. So you do want to check whatever quotes or whatever is executed, that it's okay. Okay, you might be the only one running the code, so that's fine. But if you are working on a shared code base, 1 comma, 1 something change or a quote can actually create a big difference on the server. So it's another thing, input-output checking. I don't see a lot of people doing it, but I think there is real value in doing that. And then another thing we learned is that we started doing all this coding stuff. And the admins as over said, we got this jar file or whatever, and it has the hard-coded part of our GDBC or whatever. Can't I just learn to give us a config file where it's all specified? Well, funny thing was they did the same with their infrastructure as code. There were hard-coding paths where the files should be, or they were doing that. So after a while, people said, okay, maybe, think Java profiles. I can give a profile, so a list of properties that I would run with my code and then have it applied. That's how they kind of extract the config from the code so it can reuse. I kind of feel almost sad that I have to tell you that this is the way we've learned it, but that's the way it is. And you as a coder, you probably are familiar with a lot of these practices that in code have been there for ages, but that's the way it is. So I mentioned about like hard coding paths, is that it's so people see, okay, I need to install Hadoop. That's fine. So they go on the internet and they find either a Chef or a Puppet or something else. And say, okay, let's use that language. It's funny how that's one of the first deciders on what language you're going to use. It's like, what example did you find? What can you try? What fits my problem? Which makes sense. But then there's the first thing they do is kind of, because of the inheritance, it doesn't really fit my need. I need to have, like, the user has to have another ID, or it has to have another path. So they kind of do copy and paste. They don't worry about, like, the inheritance or feeding it back to the community. Some do, But there's a lot of forking going on from these modules, a lot more than we have to. Like, if I write a module that has to support upstart or the traditional initd or all these different ways of starting my service, traditionally, a lot of people would just fork that into different ways of running the service. Where if you design your modules correctly, you would say, okay, there's a parameter that says what kind of service are you running, and you specify that into your module, and then it says, okay, now I'm using upstart, now I'm using something else. It's just a simple example, but there's a lot of it that drives people currently to just fork the existing thing and not committing it back. So we need to get better at this. Okay, we got the code, we got the syntax checking. So remember, if we do a check-in of code that's not syntactically correct, we do a pre-commit check. So we don't commit something that doesn't have the correct syntax. So because it's just text files, we can use the existing Git or whatever pre-commit check to validate whether the syntax is correct, or we can compile it. So that's already kind of very familiar with just regular coding that you can use. And then there's the dependency management. Again, it has taken 2-3 years to figure out, like, if I have an Apache module and I have like a Hadoop and I have a JVM, okay, it'd be nice if I can specify that Hadoop depends on JVM and that I need also the Apache, but there was no good way of specifying these dependencies. Strange. The POM file has already solved that problem for agents in Java. I say, download it from here, get this file from there, build it. But it wasn't there. So luckily, somebody actually wrote something similar. But initially, people were using Git submodules to do that. But now there's like a bundler-like of way to specify what the dependencies are. So there's all the remote repositories. But like I said before, they're very prone on being focused for one company, very focused on that problem. It's a good start, but please enhance the code and commit it back. So Opscode has one, the Forge has one, so you can look up like MySQL, whatever you want to install, to reuse the cookbook. Most of the times they work, but it's often kind of a trade-off between having something special or not. And these are not backed by Opscode or Puppet Labs, so there's all community. There's a few that they kind of try to integrate, but mostly if one has created a MySQL, there might be like 4 or 5 of MySQL because everybody has a different way of installing. At least it's better that you can take one of these, and if they fit, you can work on that. Where in the past, every system installation used to be a special snowflake, where there was no reuse. So it's still better. So I talked about the dependencies in Puppet. You would have like librarian in Chef, also kind of librarian Bergshelf. So the example shows where the code comes from. So this one comes from the community Opscode. It uses the cookbook, NTP, or time zone, a version, RVM. You can get it from Git directly. So this is kind of the POM file style from specifying dependencies. If you need to have multiple modules, you have to download them and get them together. If you start linking them with Git submodules, I found that admins are not familiar with the fact that if you put your / wrong or correct, it will check in the whole subtree or not. It's kind of scary. This works much better, much more granular. Chef has another nice thing. So they don't use the dependency tree of Puppet, but you can specify in the meta directory like where the module you're creating depends on. So this one depends on Git and JRuby. So there's a kind of meta file where you find the different parts that Chef module depends on. Yeah, okay. Once you have your code, I expressed that the dependencies between one first and the other and so on. After a while, when it becomes complex, it's hard to debug that. So people started visualizing the dependency graphs between the different modules. So you have a tool for Chef and Puppet, different, but you can say like, okay, my module is a database and a web server, and the web server depends on Apache 2 and the module Apache 2 mod SSL. So it's kind of a visual way of seeing where your code is at. There's even an online service where you can just say, here's my module on GitHub, and it just generates the whole graph of your tree. So pretty cool. It's by the same people who create the Eclipse, because they're kind of having to go anyway through all the dependencies in the editor, so they kind of release this as an online tool. So debugging, that's probably the best thing that I can show to you. Logging. It just feels so ugly when you come like from all these complex environments, and the only thing you can do is like a printf style way of putting some code there. Yeah, I'm sorry, it's ugly. This is a bit better, like there's a REPL style for Chef or Pry because it's Ruby, so you kind of can poke in the variables while you're running. But I really hope that this part gets solved in the IDE, that you can do a run and kind of go through and put like breakpoints, and because that's something that isn't out there, but something would be really useful. And there's another way, it's kind of a side thing, is that when you want to do a run on something, you can specify the inputs and the outputs of a system where you say the network looks like this, the disk looks like that. It's kind of a black box behavior testing framework. I'm just here for reference. I'm not going to go in detail, but it's an interesting approach. So we got the code. It's kind of the pre-commit checked in, but it's nice to have when you code, you need a development environment. So the way people work in infrastructure as code to do the development is that you have a virtual machine that contains, like what we said, the files, the packages, and the services, which is when you run your code. And underneath it, there's a layer which is they call the just enough operating system. It's the minimal install. It's the core install of the operating system, plus a config management tool. So there's nothing on there, just the basic CentOS install or Debian or Ubuntu and Chef or Puppet. And then from there, you run the code. But what the nice thing is that the base system you can always reuse. And then you put the system into a state, you start from the base system, and then you do the run on the machine. Of course, you're running virtualization because you don't have like all the OSs or the different versions on your laptop, so you're using some kind of virtualization layer to do that. A tool that really helps there is Vagrant. How many people have heard about Vagrant? Okay, that's cool. Vagrant actually solves that problem of managing that just enough operating system and then doing a run on your virtual machine. It's VirtualBox now. Mitchell is working very hard on getting Fusion. You can use it even if your laptop is Linux or Windows, so the tool is designed to do that. So the nice thing is that it kind of simplifies the way to set it up. So it's just define what OS you want to have, and then you can start doing run with a few simple directives. There's a few useful plugins for managing Windows systems, or DNS or hosts, because it's running in a virtual machine and you might not have a DNS and so on. And also because it's running on VirtualBox, you have to keep your VirtualBox drivers in your OS up to date. VBGuest is a very nice tool that will take care of that. So if you're using Vagrant, this is really something I can recommend that takes away the pain of having to change that every time. I learned a couple of days ago here at Devoxx that there was a Vagrant Eclipse integration, which is pretty cool. So now you can run it from your IDE. We'll like apply the code and go from there. So it's still early, but again, it's like improvement if you're used to running in an IDE. And then there's a bunch of clones. If you're not running VirtualBox or you don't want to run it, there's one for Fusion, LXC, EC2, KVM, so you can pick their own. They're not as rich as Vagrant itself, but it gets you into the same workflow, like apply the code, run the code on that system. There's also like a binding for if you're into Clojure, that you can control VirtualBox and Vagrant from there. So it might be a nice thing. And I learned also here from, there's a Java Vagrant binding that you can start controlling Vagrant through Java API, which is nice. The additional part is that you can actually integrate it in your unit test so that it runs your unit test and spins up a new VM based from Vagrant and runs that test. So it's a kind of cool addition I found from that part. Remember that GOS, the Just Enough Operating System creation, there's a tool called Vivi, which allows you to create like from scratch, very easy, CentOS, Ubuntu, Debian, whatever OS is out there, and now Windows too. Just with a few simple clicks, you get a whole installed box from scratch from ISO download to do that. It supports virtualization for VirtualBox, Fusion, KVM, and Parallels, and runs on Linux and Windows. So if you're using Vagrant and you want to create your own box or your own setting as your production is, I can recommend Vivi there. There's even the people from Chef and Puppet are taking Vivi and they're kind of automating the creation. So they are saying, okay, on CentOS, Chef should be installed like this, or on Ubuntu, Puppet should be installed like that. So they're providing those just enough operating system plus their provider as a service. So it makes it very easy if you want to test multi-OS support for your application. You just say, okay, I can now run this on multiple VMs, multiple OSs, multiple versions, and it's just managed with the same tool, with the same code. If you have a cool setup, share it, or a box, you can share it online. It's interesting to see because others don't have the luxury of downloading ISO files or big files. So if you can create that, that'll be cool if you share that. So we got the code, the editor, and then we kind of the pre-commit. Then we want to move forward. We want to run tests because what's code if we can't test it? Again, that was faster, but it took us a good while to understand it in infrastructure as code, what testing means in infrastructure as code. So this was kind of the canonical example. It's saying the catalog, which is the metadata, which is the directed graph on Puppet, will it actually compile? It's not like very useful for as a unit test per se, but it's very useful in Puppet because if you didn't include like a file or a service, well, you do want to know whether your compilation or your directed graph is actually valid. So that was kind of the early canonical example of running a test against your code. Then it got more complex, and people say, okay, but I can now test whether the class Java has run, or syslog is installed, or Elasticsearch is not installed. Because you are doing logic and say, okay, on this machine, depending on these settings, I want to have this test running. So people started using RSpec kind of syntax to specify their tests for their infrastructure as code language. I think that people are still struggling. Is that useful? I think it's tremendously useful if you're doing a lot of logic in your infrastructure as code. If you have very, very simple things, it's not worth it. So the point that I want to make is that if you say declare install service A, there's no value in testing that service A got installed because then you're testing Puppet. It's the same that you would test a library like Spring or Hibernate. You don't duplicate the testing of that. But if you write logic, say, on this OS, and given that this file exists, and it's doing this, then you should run Java or install Java, and if not, do something else. That's the kind of logic you want to test. So there's where you test is useful, not for checking what Puppet or Chef is supposed to do. Even though Chef and Puppet might lie to you, like you say service Apache start, and it will tell you like, oh, Apache started successfully. But might be that there's an error in your exit code of your start script. So it lies to you and says it's up while it's not up. So it's kind of a dilemma, but it's not the function of Puppet or Chef that you're testing. Then there's an error somewhere else. So if you're doing the tests, I told before, you want to fake the facts. The IP addresses, the versions of the hardware, the number of CPUs, all things that you can decide or that you make decisions on in your business logic, in your code, that you do it. So you can mimic a Debian machine and see if it installs the right package. You can mimic a multiple CPU system where it uses the correct flags in the config file. So that's kind of what you do, fake the facts. And for Chef, there's a library-specific Foxeye which allows you to kind of mock the requests so that when you do a run, they will say, okay, this is an Ubuntu machine with this version. So it's kind of what you're, again, used to as code. And then you will find yourself saying, okay, I want to have this feature in my code. You edit it. And then you have to do a run, which is going to take time. It's not as fast as compilation and a run as regular code. And then you'll see the result and see what happens. So the next thing you do is just, you know what? Every time I do an edit change, just run it. I don't care. It's just give me the feedback. Because then you're getting away of just always having to type, okay, I need to do a run, I need to do a run. It might vary, but I found it useful just to do it in the background and give me feedback whether the run was successful or not. It almost gets you in the TDD cycle, like, okay, you write actually what you want to do, and then you start implementing it, and then it goes green again. So it's not the perfect analogy, but it kind of gets you going. If you're spinning up real VMs like Fusion boxes or VirtualBox, the problem is that creating a new box is expensive. Just starting, you know, we were all used to waiting until our machine boots, and that just still takes time. So there's a few tricks or tools that take advantage of Linux containers, which have a boot up time of about a few seconds, and they're spinning it up in LXC, doing a test and disposing the environment. So this can really help if you're doing a lot of tests that really require the machine on your local environment to speed it up instead of you having to run it every time in your Vagrant environment. Okay, we've written our tests, we got the code, it checked in. So let's say our commit is supposed to be valid now. The next step is just go for the continuous integration part. I've talked about the lint kind of syntax testing and the RSpec testing. They both don't require a real machine. So both languages are very close to Ruby, so it's often a rake task that you can use to just run the scripts and get some exit code and feedback. What's useful is there is a JUnit processor for Ruby, CI reporter, which makes it really easy to hook it up into your CI system, because then you can just have the results of your unit tests in the regular syntax, so your build tools pick that up as the correct exit code and errors and so on. So there's a difference. You can run syntax checks, unit tests, and compile checks, and you don't need the VM. But for smoke tests, you're actually doing it on real VMs. So the difference there is you create a VM, like we said before, which is a minimal VM, maybe with some extra on it. You do a code run, it gets into a new state, and then you run the test to see whether your code run has actually achieved the state where you want it to be. So that's kind of the moment where you do the smoke testing. Whereas the unit testing and so on, you can just do wherever without a real machine. One of the first kind of tests there was an integration called Cucumber Nagios, which after the run would test, let's say, this is now the example of Google, but here you would have it point to your own web application and say, if I go to this URL, I do this, and so on. It's kind of the traditional end-user testing or end-to-end testing tools you use, but you can do it, you reuse it actually for your infrastructure as code as well, even if you're not applying a new your new application, but only doing admin stuff, it's still valid to check whether the URL or service or ping response, that's kind of the checks you do. As a bonus, Cucumber Nagios had the fact that you could reuse the same logic you put in your Cucumber logic for your monitoring system in Nagios. So often there's a duplication between the code that you're running in the tests and the code for doing the same logic actually in your monitoring system. So what was nice that in this system you could reuse the same logic. So then they started working on reusable steps because a lot of people were duplicating. I need to check whether my service is up. I need to check if this command gives the correct exit code. So there's like Qcon who tried to kind of put together all the reusable Cucumber steps, so you can have a look there at reusable chef steps, puppet steps, or CLI steps, or stuff like that. So I mentioned we have applied the code to the system, so now we want to do the test. What Minitest and Puppet Assert do is they run the test within the same cycle of the Puppet or the Chef run. And the nice thing of that is that you get access to all the variables and the settings that you're having during your Puppet run. Because if you're doing a code run and you're doing your tests separate, you have to duplicate the checks to know the state you were in on that machine. But if you do it in the same run, you can actually just look at the variables in the run. Of course, if the run fails, you have to take care that your chef handler is still run, but because they are run at a report level after the run, they can actually, they will always be run at that level. I told before that VM creation is expensive. Another way to get around it is when you do the code run, before doing the code run, you take a snapshot on the system. Because taking a snapshot and doing a rollback on a VM is much faster than actually booting from zero the whole VM. Be aware that this gives side effects if you're doing time-based stuff, because you're actually resetting the snapshot to an older time, and then you're applying new time. So be aware that if that doesn't catch you, if you're going back from snapshot. But this is, for example, how Nokia uses it to scale their testing farm to give faster feedback to people running code tests, just roll back from the snapshot. And Jenkins also has a plugin, Vagrant plugin, that allows you to do the snapshotting and the run before you. So you might want to have a look at that. Actually, Travis CI is using Vagrant and Vivi to create the base boxes and to run the tests inside real VMs. So this is like a service you can use outside. You don't have to run it inside your company, but it's leveraging the same technology. So whatever you prepare locally, you can just delegate and have it run on the tests in Travis CI. If you're on Windows, you might want to have a look at Bill's Kitchen that kind of puts all these tools together, because compiling kind of Ruby tools and Linux kind of oriented tools together, it takes some time, and this project's actually trying to work its way through to kind of make them all together, but specifically working on a Windows environment. What we found at Atlassian is that when you start creating a lot of infrastructure as code, you will have a role, saying a web server role, or log server role, a monitoring role, and this number of roles just keep on exploding. If you're managing a lot of different types of machines, they will depend on modules. So two different roles might depend on an Apache module or a Java module and so on. If you were to do naive testing, saying, whenever I do a code commit change, I will run the tests on all different types of OSs, on all different roles. Imagine how many different roles and VMs you have to spin up for that one change in code. Okay, you could postpone that until the end of the day if you're lazy, but if you're doing infrastructure as code development, you want to have feedback faster. So how do you do it? It's kind of, remember that Puppet has that meta model. You can query, hey, the role depends on the module. So if this module has changed, I can defer from the directed graph which of the roles I need to retest. And that saves me a lot of tests that I don't have to run because I can predict where the different tests need to run. So it's kind of an optimization, but if you start growing and doing a lot of infrastructure as code, this is actually becoming a bottleneck that you kind of have to run it on so many different versions, so many different combinations. Last part is actually performance and metrics. So we have the runs, we have the code. Okay, let's say everything goes okay. Like code, the more code and infrastructure as code you're writing, remember that a run, you want it to be fast. You don't want it to take for 5 minutes to run and then get the feedback. So somebody built like a profiler. So you could see that how much in each part of the run is actually spent. So you can do improvement and say, okay, this part of the code is just not performing. It's taking too long. Maybe because you're checking a URL that has a timeout or stuff like that. So this is kind of where a profiler is handy, that you can start checking this, how it evolves over time, or where your bottleneck is. If you really get fancy, you want to graph the time it takes to do the run, or the load average it took on the machine, or the number of resources, meaning the number of services, the number of modules you're using. So if you start graphing that, you can see the trend, how your code's evolving. So it's a useful metric. Again, if you start doing a lot of it and a lot of changes, how things will actually evolve over time. So for kind of my conclusion, it is code, but not as we know it. So my conclusion is actually like it's close but no cigar. I do want it to be much further, but it's a community of admins who've not very been exposed to development practices. They're learning. Funny thing is they're learning and going through the same curve that a lot of the languages has been. So I please encourage you as a developer to join the community and give the good example because you're so used to doing it. But I've also think I showed you it's getting close and we're getting a lot of the practices we can reuse. So it's not that little ugly scripting language somewhere in the corner that you're doing your admin stuff with. You can start expressing and testing and using the same tools as you're used to be, you used to. So this was it. Thank you for the talk.